Hello, my name is Francois, and my project is Mission Critical Cloud, or MC Squared, a peer-to-peer virtual private overlay network for mission-critical cloud computing. So I want to kickstart this discussion by using an example that I found to work really well. We're going to use our imaginations, and we're going to pretend that you are an attacker trying to disrupt this meeting or this conversation. There are a few limitations though. You can only observe the meeting, and you can see people talking, but you can't hear what they're saying. So you might be a little confused. Don't worry, John Stewart shares your pain. Continue using your imagination. Given that you are the attacker, okay, I'm going to ask you to answer a question. So given that you are the attacker, and relying on your previous experience with meetings, so using what you know about meetings already, I need you to answer the following question. Which person in this room is leading the discussion? Right? That should be fairly obvious. If you said, if we were in a larger meeting and you said the prompter, then that would be correct, or if you said me, that would also be correct. So this leads us to our problem. And we have two takeaways. The first is that communication patterns are very, very strong clues for observers, right? And the second takeaway that follows from the first is that an attacker can easily infer important components simply by observing communication patterns, right? So with these two realizations, we can go on to presenting our solution. But first I want to talk a little bit about me. My name is Francois Dugard. I'm a senior undergraduate student at Florida International University. I work at the Virtualized Infrastructure Systems and Applications Lab at FIU under the direction of Dr. Ming Zhao, and I was able to do that using the Research Experience for Veterans grant. So for our project, we'll be discussing the following things. We're going to go over the proposed solution that we have. We're going to talk about two potential use cases for our solution, namely tenancy and active defense. We'll do a quick demo, and we will discuss some preliminary results. We'll go over some project details, and then we'll wrap everything up. So our solution, we're going to use our imagination again, and I want you to imagine yourself in a busy, crowded restaurant, a crowded party, and a playground. Okay? So I'm sure you've been in all three of these places. So knowing what you know about human communication, answer this question. In terms of communication, what did these places have in common? And so the answer should be pretty obvious also. Everyone was talking at the same time, right? If you're in a busy, crowded restaurant, it's difficult to pick out the individual conversations because there's so much crosstalk, there's so many people talking over each other. Likewise, in a playground or at a children's party. So you were able to infer certain things because of communication patterns. In the first example, you were the attacker, and you were able to infer who was leading the discussion because they did the most talking, right? Or because they requested the most information from other people. We have a problem because we want to hide those communication patterns from attackers. So more specifically, we want to homogenize network communication patterns, right? Or, said another way, we want to make it seem like everyone is talking at the same time, just like in a restaurant or a playground. We want to make it so that it's very difficult for an attacker to pick out individual communications and then infer which person in that group is leading the discussion, because that person is the mission critical component. So the motivation to solve this problem. Mission critical applications need to ensure their availability. Okay? They need to be able to say that they're going to have a certain amount of uptime, and they're always going to be up. They're always going to be of use. mission critical applications need to be able to ensure their availability. Okay? They also need to thwart network traffic analysis. They need to prevent and make it so difficult for attackers that it's not worthwhile wasting resources to attack them or to even analyze their traffic. So one of the potential uses for this software is in tenancy cost savings. It's probably the most cost-effective use case. So right now you can go to Amazon EC2 or Microsoft Azure or some other the cloud providers have said that the solution to this problem is to isolate your cloud from every other cloud and put you on your own dedicated hardware. The other potential use for this is in prevention-based active defense, right? Prevention-based active defense gives us the ability to prevent attackers from mapping our environment by making it too difficult for them to do so. And lastly, a tar pit defense. This defense allows us to slow by delaying initial responses. So now we have some preliminary results. We saw an overall network performance degradation. We ran our project on a small private cloud using OpenStack and a larger public cloud, Amazon EC2. We used Apache Hadoop, we went up to 10 instances, and we ran word count and test DFSIO benchmarks. And our future work will be to increase the number of instances and increase the benchmark scale. So what is MC squared? MC squared in terms of software components are two components. First, the controller, which resides on each peer and is a member of a social network, and an XMPP server, which is the social network itself. The XMPP server manages peer relationships and verifies trust among peers. This is how two different peers are able to talk to each other. And in terms of data structures and algorithms, there's a social network graph that's completely connected. And that complete connectivity is important because it's what allows us to create random network paths very quickly. Secondly, there's a core algorithm that's run on each controller every time a packet is received by the controller. And that core algorithm attempts to homogenize the network traffic and implement random paths for each packet. MC squared was produced in collaboration with and leverages the IPOP project. IPOP is developed by the Advanced Computing and Information Systems Laboratory at the University of Florida under the direction of Dr. Renato Figueroa. Mission Critical Cloud is a peer-to-peer overlay network. It disguises network traffic in plain sight by homogenizing network traffic. It can reduce monthly cloud computing costs by eliminating the need for single-tenant dedicated hardware, and it provides an active network defense solution. My name is Francois, and thank you for listening.